gals, it's time to do something new finally. Today we're going to look at sequences and series. Well, actually, we're going to start with sequences. But first off, what is a sequence? Well, it's just a set of numbers with a pattern. 2, 4, 6, 8, skip counting by twos. Any sort of patterned set of numbers is a sequence. Now, each element of that sequence is called a term. So if you're looking at 2, 4, 6, 8, the 2, the 4, the 6, and the 8, those are all your terms. We've got finite and infinite sequences. You should be able to just know what they are by their names, but finite means it has an end. So a sequence with a limited number of terms, 1, 2, 3, 4, 5. Infinite, it doesn't end. Sequence with an unending number of terms, 1, 2, 3, 4, 5, dot, dot, dot. The ellipsis. Not the ellipses, but the ellipsis. We'll talk about the ellipses in a few weeks. That means it keeps on going forever and ever and ever. I could put one on the other side of it, and that would mean, there are negative numbers and 0, all that good stuff. So realize that the ellipsis means your pattern keeps going. That would be an infinite sequence. Okay. Let's see if I can get this out of the way. Not really. That'll work. All right, the first term in a sequence for this class, we'll use a sub 1. A lot of times you'll actually see a sub 0 as the first term, but to match everything else in this curriculum, we're going to go with a sub 1. It's kind of just like, the natural numbers having 0 or not. It depends on where you're at. But we're going to go with a sub 1. You might see a sub 0 as the first term. Just depends on what it's defined as. And then each term after that is a sub some number, 1, 2, 3, 4, 5. Whatever n is the place in your sequence. So if we look at this sequence here, 1, 5, 9, 13, 17. Well, first thing you want to identify is, what is the pattern? Well, we're adding 4 each time. 1 plus 4 is 5, 5 plus 4 is 9, etc., etc. So it says a sub 1, that's the first term. Well, that's a 1. A sub 4, let's see, the first, second, third, fourth. That's a 13. Fifth, we don't know the ninth. We need to continue the pattern. So just keep adding 4. 17 plus 4 is 21. 25. Let's see, we need a sub 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a sub 9. And we keep going to 12. 10, 11, 12. So 45 is a sub 12. And it's a subscript. You just read it a sub whatever number that is. Some people say A1, A4, A9. I like to emphasize that's a subscript. So you're talking about the domain and the range of these things. The domain is just how many terms you have. 1, 2, 3, infinitely many, whatever you got. The range is whatever your outputs are. It's the values. So if you're adding 4 each time, it would be 1, and then 1 plus 4 is 5, etc., etc., etc. So these are the inputs, the term numbers, the outputs, the term values. And the domain of infinite set would be your natural numbers, excluding 0. Again, it depends on who you're talking to. We'll just go with the naturals. Again, realize it really depends on whatever your professor's telling you. For me, we can go with it. Natural numbers minus 0, or you could write 1, 2, 3, ellipsis. That would work for me too. Rule in which so recursive formula. It means you've got to know what's beforehand in order to get what's next. A rule in which previous term or terms, might be more than one, are used to generate the next term. Great example is the Fibonacci sequence. So this guy's all over the place in nature. I mean, you can look them up. The golden ratio, Fibonacci is everywhere. If you expand a binomial, x plus 1 to some power, these are going to give you, oh, that's Pascal's triangle. Never mind. Similar, but not the same. Anyway. Yeah, so Fibonacci, it's a recursive formula. You take the first two numbers, which are always 0 and 1, and you add them together. That gets you your next number. You take the previous two numbers, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 13, 21, 34, 55, et cetera, et cetera, et cetera, forever and ever. It's an infinite sequence. So the formula, if we're trying to find a sub n, it's whatever the previous one is. Well, the previous one would be n minus 1 plus the one before that, n minus 2. 0 and 1, the first two terms, the first and second, 1 and 2, are always 0 and 1. So those are already defined. So what is A1? It's just 0. It's given to you. So it wouldn't make sense to try and find what is A1 here because there's nothing before it. So we know these two, and from that we can build the rest of the sequence. So all this says is you take whatever the previous two numbers are, add them together, that'll give you your next number. So here, 55 plus 34, that's 89. That'll be the next number. You could keep on going. So we're going to practice. And again, it's giving us our domain here. It's going to be a natural number greater than or equal to 2. So it wouldn't make sense to say a of 0.5. So we're always dealing with natural numbers here. It says A1 is 14. And a sub n is a the previous number, so n minus 1 plus 9. So it's whatever you start with, you add 9 to it, get your next number. What's the first 5? So first one, A1, is 14. That's A1. That's the first term. The next term would be A2. To get A2, I'm going to take A1 plus 9. Well, that's 23. A3, that's 32. A4, oh, that's 41. And A5 gives us 50. So this is a recursive formula. We had to know the previous number to get the next number. Let's try this one. It tells us that the first number is 6. And it tells us to get the next number, we need to double that number and subtract 5. That's what this formula says. Multiply a sub n minus 1, that's the previous number, times 2, subtract 5. So, do red. So A1 is 6. If we double 6, that's 12. 12 minus 5 is 7. That's A2. 14 minus 5 is 9. That's 3. 18 minus 2 times 9 is 18, minus 5 is 13. It's 4. 26 minus 5, well, that's going to give us 21. So the pattern is double minus 5. Probably want to use a calculator for some of these. You know, your arithmetic gets complicated, tricky on you. Or if you have a big number like this and don't feel like thinking about it. So again, we're getting the first 5 terms. So A1 is given to us. It's a recursive form. We got to start somewhere. 354. To get A2, we're going to take that number, add 6 to it, and divide it by 3. 354 plus 6 is 360. Divided by 2, or divided by 3 is 120. Yeah, definitely just go ahead and grab the calculator. So I'm plugging in a number. I'm going to put it in parentheses. 354. I'm just going to double check. Plus 6 divided by 3 gives me 120. Good, I didn't screw up. Oops. So now I'm going to plug 120 in. I get 42. That gives me a sub 3. Now, a trick with the calculator for recursive formulas is you can actually just use the answer button, because that's automatically going to plug 42 in there, right? Now it's 16. And you can check. 42 plus 6 is 48. And yeah, 48 divided by 3 is 16. But then I can just hit enter again. It's going to use 16 as my answer. 22/3. Okay, well, you might be like, hey, that doesn't seem right. So check it. If I plug in 16 here, sure enough, it's 22/3. Just because our term numbers have to be natural numbers doesn't mean our term values will be. So we could get fractions, or heck, depending on the formula, it might even get radicals. Who knows? Just depends on what's going on in here. So it's okay to have fractions. Let's look at the next one. This one defines the first two terms. So we already have the first two terms out of the way. A1 is 3. A2 is 4. To get the next one, we multiply the previous two. Okay, that's what it says. The next term is equal to the previous term times the term before that. Well, I can do that in my head. 3 times 4, that's 12. And 4, well, that's easy. 4 times 12 is 48. A5, less easy. That's 480 plus 96. That's what, 576. Let's just use a calculator. 12 times 48. Yeah, 576. So definitely want to use a calculator because it gets to be using that brain power. Don't need to stress. You got a calculator, use it. All right. So now we're told to find the rule. We're given a pattern. We got to find out what it is. We got to write a formula for that pattern. And then we're going to give the next 3 terms. Okay, let me see something. Yeah, okay, we got it. So we're going to do a recursive formula. How did I get from here and here to here? Top of my head, I haven't the slightest idea. Let's see. If I multiply that together, let's see, 4 times 11, it's 44. To get to 32, I could subtract 8. Let's see if that works for the next one. I have no idea, by the way. What's 11 times 32? Nope, that's gonna be way too big. Okay, let's just go with the 4. Wait a minute. What if we just double that? What does that give us? So yeah, it's a lot of playing and guessing and checking. This is all about, can you see the pattern? Let's double it and add 3. That gives me 11. What if I do 11? Nope. Triple it and subtract 1. So I'm just playing around trying to figure out what is the pattern. So if I do 4, I know that's how I got the triple minus 1, because I knew 4 times 3 is 12 minus 1 is 11. So that works. Does it work for the next one? Hey, it looks like we might have a winner. Still working. Yes, okay, so we found our rule. Sometimes it's easier than others. Sometimes it's based on 2 numbers, sometimes it's not. So if I'm going to write this out, our next term in our sequence, a sub n, is equal to, let's look at the calculator, it's 3 times the thing minus 1. 3 times, what's the thing? The previous term, a sub n minus 1. Minus 1. I'll tell you, some people are great at finding these, some people suck at it. I'm not that great at it personally. But just figure it out, you'll be fine. Well, I'm looking at it's going down, so I'm doing something that's either going to be subtracting or dividing. It looks like I went from here to here is 40, from here to here is 20, that's half. So somehow I'm taking the previous term and each time subtracting half as much as the previous time I subtracted. Because that's 40 is the difference, 20, 10, 5. I'm looking at the differences here. I see the pattern in the differences. If I just subtract those, that's not going to work. So 100 minus 60, that is 40, but 60 minus 40 is not 30. But that difference, 100 minus 60 is 40, 60 minus 40 is 20, 40 minus 30 is 10, 30 minus 25 is 5. So that difference is what I'm going down. Okay, well let's write that. It's and again there could be multiple formulas. So if I do 100 minus 100 minus 60, that gives me 60. Well, that's not going to help because I needed the 60 to get the 60. So that's, but I need to take half of that. If I do 60 minus that divided by 2, that gives me 40. So now I'm going to change that to a 40, that to a 60, that to a 40. I think this is going to work. 30. Okay. So let's write this out and simplify it a little bit. I've got, if I distribute the, let's call it x and y for a second. Let's just play around with this. Let's call the next number x, this number y. So we did x minus y minus x over 2. This would be a sub n minus 2 minus a sub n minus 1 minus a sub n minus 2 minus a sub n minus 1 over 2. We can simplify that a little bit using the distributive property. And combine our like terms. Okay, so this should work. So if we do 3 halves times x was the previous term, oops, over 2, minus the term before that over 2, should work. Now, I have no idea if this is the formula they wanted. Yeah, that's what I came up with. Let's see if there's actually something easier we could do. Let's see what they came up with, because This is pretty nasty. Okay. It's a half of the previous term plus 10. Okay. So yeah, this looks like it's going to work. I mean, there could be multiple patterns here. Let's make sure it works for these, the 40 and the 30. This was 40. That's 30. We should get 25. Okay, so this works. It's complicated and nasty, but it works. Another formula that works is right here. You take half the previous term and add 10 to it. Well, that's easier. So based on this particular sequence, there's two different formulas. This nasty one we came up with and the next one they had. So let's go with the one they had. Let's make sure it works though. So it's half of the previous number plus 10. So 100 plus 10. 60. Change that to, let's say, 30. 25. Okay. That works. Let's go with that. This other formula would not be wrong. It's just more complicated. So a sub n is half the previous number plus 10. So if we plug in 25 into here, I wonder if it'll work for this one. We'll find out. Let's see if we get the same thing in a minute. This is going to be a fraction because 25's odd. 45 halves. Oops. All your directions. Next three terms. I didn't do that for this one. We'll go back to that in a second. So the next term of the sequence is 45 halves. That would answer because the recursive form makes it easier. 85 fourths. 165 eighths. That's the next three terms. Let's see if we get the same thing using our complicated formula. I don't know. We could get something different. 25, and then the number for that would be 30. We get the same thing. 25. This is 45 halves. Let's see. It looks like it's somehow the exact same formula, guys. Okay, see, it's just two different ways of representing the same formula. My bad. Let's go back to number 5 and finish writing these terms. Let's see what the next term is. Now that we have the rule, it's easy. So I'm just type in 284 and hit equals. Now 284 is my answer. So if I do 3 times my answer, that's a sub n minus 1, minus 1, I get 851. Followed by, hit equals again, 2552. And hit equals again, 7655. Sorry about that. Okay, let's keep going. Explicit formulas. So these are formulas that do not rely on the previous terms. So if we look at a sub n, it's going to have a function of n instead of a function of a sub n minus 1 or a sub n minus 2, anything like that. It doesn't need the previous terms in order to find out what your 100th term is. I mean, a recursive formula works, yeah, sure. This formula works just fine, right? But what if I ask you for the 100th term or the 1,000th term. You'd be there a while. And your calculator would probably run out of memory, so that wouldn't work. No, not going to happen. Which is why we need to figure out how to get an explicit rule, one that does not rely on previous terms. So here is the rule. Okay, remember, we're starting our sequences at 1. N is 1, always. So if we want a sub 1, I'm going to just go down this way. We can type it in. 7 times 1 minus 3. Yeah, I put it in parentheses. Anytime we plug in something, put it in parentheses. Just get in a habit so you don't screw up. Yeah, negative 14. Plug in 2, I get negative 7. So a sub 2, negative 7. Now I'm looking for a sub 3. So see, that's where whatever term we want, the third term, the fifth term, the 100th term, doesn't matter. We can just plug it in this formula and it'll pop it out. So A3 is 0. A4 and A5 are what we need next. So that's 7 and 14. Okay. So if we look at this rule, it's just multiples of 7, right? So it starts at negative 14 and just multiples of 7. Okay. Number 8. Let's see. We've got a fraction. Who cares? Just use your freaking calculator. If I want A1, I'm just going to plug this formula into my calculator. Parentheses, fraction, 1/3. Make sure your parentheses is in the, not in the denominator. Power n plus 1. 1/9. These are just going to be fractional powers of 3, right? So next up is going to be 1/27, then 1/81st, and then whatever after that, because I don't know what power of 3 after that. And let's see what we got. If I change that 1 to a 2, I get 1/27. If I change that to a 3, that's going to be 1 over 81. 1 over 243. And then 729. 1 over 729. That's it. So explicit formulas are pretty easy to deal with. Not necessarily so easy to come up with, though. So using them is very nice and handy. But sometimes coming up with them, yeah, we're going to do that in a few slides, is tricky. Okay, let's do this. All right, so this is what we need. Let's figure it out. If I plug in 1 in here, that's negative 4. Negative 4 times 1 squared. Negative 4. If I plug in 2, negative 16. If I plug in 3, 36. Plug in 4. Negative 64. Plug in 5. There we go. That's the first 5 terms. Yay. So now we got a more complicated formula. Just take your calculator and plug it in. That's all you got to do. What am I plugging in? The 1, 2, 3, 4, 5, whatever term we want. Just remember to change both pieces. Go ahead and put both of them in parentheses. 3 times n plus 5. That's 12. Both of those 1s to 2s. 28. 2s to 3s. 48. And as you can guess, I'm going to change those 4s. 2, and finally 5. That's all you got to do, people. Just plug in some numbers. Keep going. That's the sequence. Yeah, might as well. I was going to skip them, but it's only 2 more. Might as well do them. So that's a 1, obviously. Anything with 0 power is going to be 1. That's going to be negative 2. This is just powers of negative 2, right? So it should be mental math. 4. It's negative to a power, so every odd power we're going to have change signs. 8. And then that's going to be positive 16. Feel free to use your calculator, but negative 2 to the 1 minus 1 is 1. 2 is, oh, then put the negative. It's negative 2. 3, 4. 4, negative 8. 5, 16. Yeah, it's just the powers of 2, but it's a negative 2, so you change your sign on all the odds. It's going to be negative on the odds. Well, even terms because it's n minus 1, so the even terms will be odd powers. Let's look over here. 1 minus 4 is negative 3 squared is 9, so all these are going to be positive. That's 4. That's 1. That's 0, and that's going to be 1 again. This one's pretty easy to do in your head. You're squaring wherever you do. 1 minus 4 is negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 5 minus 4 is 1 squared is 1. I'm just going to go back up. 4, 9. That's just a perfect squares. All right. So yeah, so now we're going to write an explicit rule, okay? So we want to define a sub n as a function of n. We don't want a recursive formula, we want an explicit formula here. So to do that, the first thing I try and figure out is how do I get from one to the other? Am I having factors? Am I having difference? What? It looks like I'm going down 2 each time, right? That helps a lot. So it's negative 2 times n. I know I need to do that. Now I need my first term to be negative 7. So if I plug in a 1, that would be a negative 2, so minus 5. This should work. Let's try it out. So I'm going down 2 each time, so that's my factor, -2. And then how do I get to my starting point? I gotta go 5 below -2. So let's see, double check that this works. I get -7, and then if I do like 4, let's just see if that works. -13, 1, 2, 3, 4. Okay, this formula will work. So yeah, I saw that I was decreasing by 2 each time, so that's a factor of -2 on my end. From there, I just need to figure out where to start. To get, if I did -2 times 1, that gave me a -2. To get to -7, I need to go down another 5. That's how I got that -5. So that was pretty easy to figure out. Let's see here, I'm doubling it, but not here. I'm adding 3? No. I'm noticing this is 27. So if I square that, it's going to give me 9. Yeah, again, it's a lot of just thinking, figuring it out. And I guess I could have cheated and looked at the answer ahead of time, but I wanted to see that, yeah, it's a struggle for me too sometimes. Some of you might be like, you're an idiot. This is the formula, obviously. I'm not great with patterns like this. So if you see it, holler at the screen and maybe I'll hear you. Oh wait, no, so I've already made the video. Let's see. It's 2 more than the perfect squares. Yeah, that's it. It's 2 more than perfect squares. So I need some sort of square plus 2. 1 plus, yeah, that works. 4 plus 6, yeah, 9. Okay, there it is. Whew, found it. Again, we got to get the next 3 terms. So yeah, these look kind of weird. It's not a difference. It's not a product. So try squares. That was the next thing that popped in my head. So let's triple check this thing. 1 squared plus 2 is 3. Let's go with 4. The 4th term should be 18. 1, 2, 3, 4. It is. Pretty safe here. And then we can check, make sure 5 works. But yeah, it's going to work. We got this. We figured it out. Now it says get the next 3 terms. So I'll get these first, since I already got the formula right there. If I do that, it's 38. Again, it's just the perfect squares plus 2. So 7 squared is 49, so that's 51. 64, 65, 66. 7, 8. Over here, we're going down by 2s each time. So, I mean, if we're getting the next ones, we might as well just use the recursive formula, just subtract 2. So -17, -19, -21. And if we want 1, 2, 3, 4, 5, we can see, plug in 6 here. Hopefully it'll give me -17, otherwise I messed up. Okay, I didn't mess up. Plug in 7, plug in 8. Same thing. Okay, let's see what they were going to throw at us next. Okay, we got some sort of fraction thing going. This is looking crazy. We're turning from a fraction and then now to 2, 3, 4. Oh, we're adding a half each time, maybe? 4 halves, 5 halves, 6 halves, 7 halves. Okay. So we're just adding a half each time. Whew. That 2, 3, 4 really helped me out there. It's like, okay, we're just getting, this is 1 between each other, so that's a half between each other. Cool. So we're adding a half, so that's going to be my factor. A half times n. Now I need to get to my starting point. If I plug in 1, I get a half. I need to add another 3 halves in order to get to 2. this should work. Let's try it out. And again, you know, it should be a sub n equals on all of these. My bad. I was excited for the formulas. Then write the a sub n equals. Let's try it out. And let's go with well, that's how it's going to work for 1, so we just made it work for 1. So let's plug in 2. Good 5 halves. We do. I plug in 3. Okay, it's working. I plug in 5. I should get to 4. Yeah, okay. Now this time I'm going to go ahead and get the next 3 terms. So I already have it in here. You could just do it the recursive way, saying we're adding a half each time. So that's 7 halves, 8 halves. This is going to be 9 halves. Plug in 6, we should get 9 halves. 10 halves, 11 halves. Done. There's a square root involved. It's just the square root of n. That's easy. Okay. Square root of n. Square root of 1 is 1. Square root of 2 is square root of 2. Square root of 3 is square root of 3. Square root of 4 is 2. Square root of 5 is square root of 5. That one was super easy. Don't even need a calculator for the next term. Square root of 6. Square root of 7. And then 2 square roots of 2. What? Yeah, square root of 8. Don't forget to simplify. If you don't know how to simplify, your calculator does. Square root of 8 is 2 square roots of 2. Okay, is that it? I think that's it. That's it. Okay, that was sequences. The next thing to talk about, which is not today, is series, which will be adding terms in your sequence. We'll get there, but first let's just focus on sequences, all right? So that's that. Have a good day, goodbye, good night, whatever. See ya.